Hi guys, and welcome to your first video for Algebra 1. Today we're going to be covering some foundational skills that I'm sure you have from your elementary and middle school math education. Specifically, we're going to be talking about absolute value, order of operations, which you may know as PEMDAS, talk about fractions, simplifying algebraic expressions, and then evaluating algebraic expressions. So at any time, feel free to stop the video, rewind, rewatch, take the notes that you need to make sure that you are well equipped to cover all this material. Alright, we're just going to get started about absolute value. We talk about absolute value of a number as its distance from 0 on a number line. As a result, the absolute value is never negative. The way that we could show this on a number line would be just to put a point on, such as a point here at 2. Because 2 is 2 units away from 0, we say that the absolute value of 2 is 2. And the way we would write that is we put the 2 in a couple of vertical bars, and the absolute value of 2 is 2. Alright, let's take a look at another example. Now we've put another point at -4. And -4 is 4 units away from 0. Therefore, we would say that the absolute value of -4 equals 4. Absolute value is never negative. That's something I mentioned down here, but it's never going to be negative. And I didn't do a great job up here. We probably want to make it a little bit more clear exactly how that goes there. Those are vertical lines bigger than the 4. That's an important piece there. All right, how about one more example? And now we have a point at 0. And 0 is not away from 0 at all. It's exactly there. So its absolute value is actually 0. And I include this example to emphasize the point that absolute value is not always positive. It's just never negative. It's either going to be positive or 0, depending on what it is. And that's just a quick refresher on absolute value. All right, so now we're going to do a quick review of the order of operations, which we know as PEMDAS. We have, starting off with P as parentheses, or any other grouping symbols. So that would include brackets. Absolute value is actually a type of grouping symbol. The numerator and denominator of a fraction would be included as part of a grouping symbols. And so that we have that. Next we have E for exponents. Then we have M and D together, which is multiplication and division from left to right. And finally, AS is addition, subtraction from left to right. So we're just going to do this example that we have here. I have 2 squared times 14 minus parentheses 6 plus 3, close parentheses, close brackets, divided by 10, plus 16 minus 2. So we're going to go through this, and we're going to look first at parentheses. You notice that I have these grouping symbols here, the brackets, and then inside those even further, the grouping symbols of the parentheses. So we go to the innermost parentheses first, or grouping symbols first. I'm just going to rewrite what else I have. 2 squared, and I'm going to just write a dot instead of an X for time, since we're going to primarily just be using a dot. 14 minus the 6 plus 3 is in parentheses, that becomes 9. Divide by 10. And then I'm just going to squish it onto the end here, plus 16 minus 2. Now I'm still looking inside the next set of parentheses or grouping symbols, which are located here. And so I'm going to do the 14 minus 9. So 2 squared times 14 minus 9 is 5, divided by 10, plus 16 minus 2. Now, I'm done with parentheses and all grouping symbols, so I go to exponents, and I have an exponent right here. 2 squared, which means 2 times itself, total of two 2's. So 2 times 2 is 4 times 5, divided by 10, plus 16 minus 2. Now, step 3, multiplication, division from left to right. So I have a multiplication and then a division. That's the order that I have to do it in. And so I'm going to get 4 times 5 is 20, divided by 10, plus 16 minus 2. Then the division, 20 divided by 10 is 2, plus 16 minus 2. And finally, our last step is addition, subtraction from left to right. So I have an addition and then a subtraction. 2 plus 16 is 18 minus 2, and 18 minus 2 is 16. And that is our final answer. All right, hope that review is helpful. All right, so let's talk about fractions real quick. In class, we've talked about fractions and mixed numbers, and we know how to convert between mixed numbers and improper fractions, and how to turn a fraction into a decimal or into a percentage. We're just going to talk about some operations on fractions very quickly today. And when we're trying to solve a problem like this here, 1/2 plus 3/4 divided by 3/5, order of operations still applies. So I actually have to do this division before I do the addition. Now, to do division of fractions, I have to multiply by the reciprocal of the second fraction. So I'm actually going to just rewrite this as 1/2 plus 3/4 or 3/4 times 5/3. And so that's what I end up with there. That's my new problem. Now, in order to multiply here, I'm going to multiply across the numerator and the denominator. And so I have still the 1/2 plus, and then 3 times 5 gives me 15, and 4 times 3 gives me 12. At this point, I actually probably want to reduce that fraction. What I'm going to notice is that 15 and 12 both are reducible if I divide them by 3. And this is something you can do in a fraction. So what I'm really looking at here is 1/2 plus 5/4. Now, what I could have done earlier, if I come back up to this step, is when you have a multiplication set up, you can cross off something in the numerator with something in the denominator if it's being multiplied. And so if I cross those out, leaving 1s, I would have had 5/4 like I ended up with. But either way works. Now, in order to add or subtract these, I'm being asked to add them, I need to get a common denominator, which here is going to be 4. In order to get that, I multiply the first fraction by 2/2. Just a really fancy looking 1 is really all that it is. Now multiply the way that I know how to. 2 times 1 is 2, 2 times 2 is 4, and then I'm going to add that to 5/4. Finally, now that I have a common denominator, I add the numerators. 2 plus 5 is 7, and I keep my denominator, which is 4. If I wanted to convert that into a mixed number, which I could, I just do 7 divided by 4 is 1, with the remainder 3. I keep the 4 as my denominator. I can make it into a decimal by doing division. 3 divided by 4 is 0.75, so this would be 1.75. And any of the 3 of these would actually be an acceptable answer. All right, hope that clears some things up. All right, when you're being told to simplify an algebraic expression, you're generally not going to be able to get a number for an answer. You're going to end up getting another algebraic expression, meaning something that involves operations, variables, and numbers. Sometimes variables or numbers will disappear as a result of it, but for the most part, they'll probably still remain in your answer. In order to do this, you have to combine like terms. Now, like terms have the same variables and exponents, and only those terms can be combined with addition and subtraction. You can't combine a 2x and a 3y by addition or subtraction. You can multiply them, but you can't combine them with addition. So if we look at this here, we look to try to follow order of operations, but inside our parentheses we don't have like terms. So instead I have to use distributive property, which you probably remember, requires us to distribute our coefficient to inside the parentheses. And when we do that, we multiply. So we do 3 times 4x is 12x. 3 times 5y is 15y, and that's positive, so I'll say plus 15y. Now in the second set, I'm actually distributing a -2, which is important because then the -2 times the 3x is -6x, and the -2 times -7y actually becomes a positive 14y. Now I have to go and just combine like terms. So I see this is a 12x, that's a minus 6x. They have the same variable, and the variables have the same exponents, so I can combine them with addition, or in this case, subtraction. 12x minus 6x is 6x. And then I look at the other terms, which are 15y and 14y. Once again, same variables with the same exponents. 15y plus 14y is 29y. And that's all I can get for a final answer. I can't simplify any further. So a lot of times people will try to get an answer. What does x equal? But that's not the case here. We're just combining our like terms to simplify the expression. All right, one last thing to look at. When you're told to evaluate an algebraic expression, your goal is to get a numerical answer. We're going to do this by plugging in a value for x or y or whatever variable we're using, and then following the order of operations. We have to be extraordinarily careful with negatives here. And my suggestion when we plug in is to plug in with parentheses. So I'm going to rewrite my equation, or my expression here, excuse me. But instead of the x, I'm going to write a negative 1. And I'm going to write it in parentheses because that's very helpful for me. Then I have 5, negative 1 squared, plus 7 is negative 1, minus 6. And that's all that there. So now I use the order of operations to simplify, and I want to simplify the numerator, and then simplify the denominator, and then see if the fraction will reduce it all. So in the numerator, I have exponents first, and I have to do negative 1 squared. And that means negative 1 times negative 1, which is actually positive 1. That positive 1 times the 25 is going to be 25. So I'll just start with that part there. And then I'll have the minus 9. And in the denominator, I'm going to have a similar thing. I'm going to have negative 1 squared is negative 1 times negative 1, which is 1, times 5 is 5. Plus 7 times negative 1 becomes a minus 7, and then minus 6. Now I'll just go left to right in each part here. My numerator was 25 minus 9, which is 16. My denominator is going to be 5 minus 7, which is negative 2. And then negative 2 minus 6 is negative 8. And 16 over negative 8 actually reduces. And so 16 over negative 8 is negative 2. So this expression is evaluated when x equals negative 1 to be negative 2. And there you go. That's your first review. Hope everything makes sense.